In a previous example, I was doing a problem with a primary alcohol and performing later an A2 reaction. And for that, because OH was a bad leaving group, what we did in that occasion was transform this with tosyl chloride into a better leaving group and OTS. And then you can do from this point a substitution or an elimination. However, this strategy doesn't work if you have a tertiary alcohol, as we have in the example. And it doesn't, we will not form, for example, we cannot make an SN2 reaction out of a tertiary alcohol because it's too much steric hindrance. So we have another strategy to make OH a better leaving group than changes in functional group or changes in the molecule. Here, our goal is to go from a tertiary alcohol to a secondary alcohol. How do we know that? Remember to recognize that you are going to see what is at your alpha carbon and how many carbon chains do you have there. So you have 1, 2, 3. So it's a tertiary alcohol. Here you have 1, 2 carbon chains. So secondary. I need to make that change. For that to happen, now what I'm going to be using is then acidic conditions. And let's make this a little larger. If I use, for example, diluted sulfuric acid, I'm going to protonate this, and let's make that, okay. If I create that, I'm making protonating at the oxygen then. You're going to have this formal positive charge. Yes, then loss of leaving group, and you will be forming the following carbocation. And that's a tertiary carbocation. That's stable. All right, but at this point, what are we going to do? Remember that carbocations are common intermediates for both SN1 and E1 reaction. So say that we do that with heat. So if we just, besides using the acid, if we add heat to that, what we're doing is promoting the elimination reaction. And that is here in the E1 path also, we always form the more substituted alkene, the more stable. So that's what we get, the more substituted. Meaning that instead of doing the elimination with one of the beta hydrogens here, you're going to do it with one beta hydrogen here. So let me label those positions, beta, beta, beta. These two are identical. So in the E1, you always want to have a more substituted alkene. So you're going to do the elimination here. So when you do that, your product over here is the following alkene, right? So this is what we have. Because again, we added heat. When we have diluted acid, under those conditions, with heat, you're making an E1 reaction. Now, what do we need to do to go from here to here? Now, I need to add an OH at this position. To add an OH there, let's say OH here, I need to add an H here. So add the more substituted. This means that I need anti-Markovnikov regiochemistry, because again, the H is going to be to the more substituted and the OH here. So what we're going to do is, you're going to do the hydration, and the way of doing the reagent that we use is hydroboration. We use borane in THF, and then oxidation, you use hydrogen peroxide under basic condition, and you're going to be adding then H and OH. So your reaction sequence then is we do this under acidic conditions and heat to promote an E1 reaction and get the alkene, and then we do an addition reaction So your anti-Markovnikov hydration of an alkene. So that's one. Now, we have another problem down below. And here we have chlorohexane, and I need to have hexane. So I am removing the alkyl halide. How do I do that? So we need an elimination reaction. And that is a secondary alkyl halide. That's my alpha carbon, right? So right here, the carbon has two arc chains, two alkyl substituents. So that's the secondary. So here what we can do is simply one elimination reaction. We can use sodium ethoxide or sodium methoxide, and you have your beta hydrogens here and here is the same. So anyways, you have two here and two there at the beta position. And all you're doing is then a beta elimination. And that, remember that beta elimination, that's a concerted process. So in doing that, you are making an alkene. So we have removed the chlorine, which we wanted. And now we have an alkene. So what do we do to go from that step? That's easy, that step. What are we doing? Adding hydrogens across the double bond. So the next step is then a hydrogenation, and we will use simply hydrogen here with platinum or palladium, and we'll do the hydrogenation to that. So that was fairly simple, involved an elimination, and again, an addition. All of these is elimination, alkane, addition. Here, elimination, addition, in that sequence to make these transformations.